Hello and Assalamu alaikum everyone. In this particular video, we will be discussing the remainder and factor theorem, which is the continuation of the previous video where we talked about the long division. So in long division, when you do the whole process of divisibility, you get yourself the number in the end, which is called the remainder. Like in this case, the remainder is equal to 3. A remainder theorem would help you identify the remainder directly, like it's a one-step process. So we will see how we use remainder theorem to find out the remainder directly without doing the process of long division. But before of that, just think about a normal divisibility, and you have, like, let's say for example 13 to be divided by 3. It's going to be 3 times 4 equals 12, and then you subtract and you will get your answer as 1. But what equation would connect the dividend with divisor, a quotient and remainder? So you would say 13 is equal to 3 times 4 plus 1. 13 equals 3 times 4, which is 12, plus 1. So that means that dividend would always be equal to divisor into quotient plus remainder. So that gets you an equation connecting dividend, divisor, quotient and remainder. So like for instance, if we had done this algebraic divisibility, then this is the dividend, which would be equal to or identical to the product of divisor and quotient, which is x minus 1 and x minus 2, plus the remainder, which is 3 in this case. So guys, this is the equation that connects dividend, divisor, quotient and remainder. Now let's talk about the remainder theorem. The remainder theorem suggests that if the divisor becomes equal to 0, and if the divisor becomes equal to 0, then the product of these two, which is divisor and the quotient, that would become equal to 0, and dividend itself becomes equal to the remainder. So since this is an identity and it is true for all values of x, I pick a value of x for which the divisor is equal to 0. That I can easily do by equating x minus 1 to 0, and when I equate x minus 1 to 0 and I get the value of x as 1, when I plug it back into the dividend, I will get myself the remainder. So this is what the remainder theorem is. I will equate the divisor to 0, and that's what you have to learn while you are doing questions, or remember while you are doing questions of remainder and factor theorem, that always you equate the divisor to 0. Here the divisor was x minus 1, I equated it to 0 and I got the value of x as 1. Now once you've equated the divisor to 0 and found the value of x, you will plug that value of x back into the dividend. So it's going to be 1 square minus 3 times 1 plus 5. That simplifies to 3. So that means you directly get the remainder 3, which you were getting earlier on by doing this long process of division. So in situations where you are just interested in finding out the remainder, you can directly use this process and get yourself the remainder. Let's have a look at another example. It says find the remainder when this is divided by this. So I don't want the quotient, I don't want to do the long process of division. I just want to find out the remainder when x cubed plus 6x squared minus 3x plus 5 gets divided by x plus 2. So the first thing I'm going to do is that I'm going to do x plus 2 is equal to 0, and that gets me the value of x as minus 2. And once I get the value of x as minus 2, I'm going to plug into the dividend. So this is going to be, the remainder is going to become minus 2 cubed plus 6 times minus 2 square minus 3 times minus 2 plus 5. I'll simplify it, and once I'll simplify it, it's going to become minus 8 plus 24 plus 6 plus 5. 35 minus 8, 27. So that means I get myself the remainder, which is equal to 27. So when you are applying the factor theorem, you have to do nothing new, nothing different. You just have to simply find out the remainder. And if your remainder comes out to be 0, that tells you that your divisor was actually a factor of the dividend. Like in this case, I take x minus 1 equals 0 and I get the value of x as 1. And once I get the value of x as 1, I'm going to plug it into the dividend. So this is going to be 2 times 1 cube plus 1 square minus 5 times 1 plus 2. So this becomes 2 plus 1 minus 5 plus 2, and that simplifies to 0. Now once the remainder is coming out to be 0, what do you get out of it? You know that whatever you have divided by, which is x minus 1, is actually the factor of this dividend. So if you use the remainder theorem to find out the remainder and the remainder comes out to be 0, then that means that the divisor was originally a factor. So you can get simpler questions like this where you could be asked that you have to find the remainder when x squared minus 7x minus 3 is divided by x plus 2. So you would say x plus 2 is equal to 0, and then you will find the value of x as minus 2, and once you will find the value of x as minus 2, then you will say minus 2 square minus 7 times minus 2 minus 3, which is going to be 4, plus 14 minus 3, and that's 15. So that means in this case, the remainder is equal to 15. Little more algebraically related questions of this particular topic, like if, for example, in this particular case, you're being asked to find out the possible values of a when this expression divided by x minus 2 has same remainder as when this expression is divided by x minus 2. So I will find out the remainder 1, which will be equal to 2 cube minus 2a. I mean, I've already taken x minus 2 to 0. That's the divisor, and I've gotten the value of x as 2. So 2 cube minus 2 times a plus a square gives me 8 minus 2a plus a square. That's my first remainder. And then I'll find out the second remainder, r2, by again putting x is equal to 2 in the second expression, which is going to be 8 times 2 cube plus 2 square minus 17. That's going to be 8a plus 4 minus 17. So this is going to be minus 17 plus 4 would be minus 13. So it's going to become 8a minus 13. Now, since the question told me that the two remainders are equal, so the remainder I found with the first dividend and the remainder I found out with the second dividend, they are supposed to be equated. So I would do 8 minus 2a plus a square is equal to 8a minus 13. And then it forms a quadratic equation, a square minus 10a and plus 21 is equal to 0. And then I'm going to have to solve this equation to find out the value of a. I can simply do the middle term breaking, a square minus 7a minus 3a plus 21 equals 0, a minus 3 and a minus 7 are two factors. So the value of a comes out to be 3 and 7. The question is also asking me to find out the remainder. So I can find out the remainder by plugging in the value of a over here or plugging in the value of a over here. Both will work because it was being told originally that both dividends have equal remainders. I find it easier to plug in the remainder in the second expression. That's a simpler one. So I'll say remainder is going to be, if the value of a is 3, the remainder is going to be 8 times 3 minus 13. That's 24 minus 13, and that would be 11. And similarly, if the value of a is 7, then the remainder is going to be 8 times 7 minus 13. That's 56 minus 13, and that becomes equal to 43. So my one answer for remainder is 11, one possible answer for remainder is 11, and the other possible answer for the remainder is 43. As I said, you can keep on getting these kind of slightly more complicated situations where, like for instance, it says the expression has a remainder 3 when divided by x plus 1, and the same expression when it's divided by x minus 2, it has a remainder 6. And now you have to find out the remainder when it is divided by x minus 3. So you have to understand that once you will use the fact that the remainder is 3 when divided by x plus 1, you will get one equation forming one equation using a and b. Then when you will use the other fact that it's divided by x minus 2, remainder is 6, so when you put x as 2 and equate it to 6, you will get another equation. So you will get two equations, and then the two simultaneous equations could be solved together to get ourselves the values of a and b. Let's have a look at that working. So I'd first of all do x plus 1 equals 0. X is equal to minus 1 because that's my divisor, which is equated to 0. And hence the remainder comes out to be a times minus 1 cube plus minus 1 square plus b times minus 1. And that simplifies to minus a minus b plus 1, which is equated to 3 because the remainder is given as 3. Now I do the same thing for the second situation being given to me. It was divided by x minus 2, so I equate x minus 2 to 0. X becomes equal to 2, and then I'll find out the remainder when it's divided. Let's call this remainder 1, let's call this remainder 2, and this remainder 2 is going to be a times 2 cube plus 2 square plus b times 2, and that's going to become 8a plus 2b plus 4, and this is now going to be equated to 6. So you can sort of simplify both the equations. This equation can be simplified as 8a plus 2b is equal to 2, or 4a plus b is equal to 1. I can call it equation number 2. And as far as equation number 1 is concerned, that's going to become minus a minus b is equal to 2, or a plus b is equal to minus 2. Now I can solve the two equations simultaneously to get the values of a and b. So if I will choose to do elimination and call this equation 1, then I can say that equation number 2 minus equation number 1 will give us what? 4a minus a becomes 3a, b minus b becomes 0, and 1 minus minus 2 becomes 3. So the value of a is coming out to be 1. And I can choose to put this value of a in any of the two equations. I find 1 to be a simpler equation to use, so I can say b is equal to minus 2 minus 1, and hence the value of b is coming out to be minus 3. So once I've gotten the values of a and b, then what I can do now is I can find out the remainder when it's divided by x minus 3. When x minus 3 is equated to 0, the value of x is 3. So the remainder will be, when I put x as 3 in this expression, b as minus 3, and a as 1. So I'm just going to do that, and then I'm going to find out the remainder. That's going to be my answer. So a is going to be 1, x cube is going to be 3 cube plus 3 square plus b, which is minus 3 times 3. If you're slightly confused, I'm putting these values in this particular expression because this is my dividend and I'm looking to find out the remainder. So this is going to be 27 plus 9 minus 9, and hence it simplifies as 27. So this is how I am able to use the remainder theorem. And in some certain situations, I could be asked to use the factor theorem, which is basically just the continuation of the remainder theorem, where I would be asked to see if a particular divisor is a factor or not. Like for instance, if I want to check when x plus 3 is a factor of this expression or not, then I can do x plus 3 is equal to 0, x is equal to minus 3, and plug this into the dividend. So when I do 2 times minus 3 cube plus negative 3 square minus 5 times negative 3 plus 2 and then I'm going to simplify it and check if it's coming out to be 0. This is minus 54, this is plus 9, this is 15, and this is plus 2. And this is not coming out to be 0, and if this is not coming out to be 0, so that means no, it is not a factor, right? Similarly, if I would try and check it for 2x minus 1, I will do 2x minus 1 equals 0, x is equal to 1 over 2. And I'm going to plug in this value into the original dividend, which is going to be 2 times half cube plus half square minus 5 times half plus 2. So this is going to become 1 over 4 plus 1 over 4 minus 5 over 2 plus 2. And if you simplify it using a calculator, you'd realize that this is going to be coming out to be 0. You also check it by just simplifying these two. Quarter and quarter becomes half, half plus 2 becomes 2.5, so 2.5 with plus and 2.5 with minus would simplify it to being 0. So that means that x plus 3 is not a factor of this expression, whereas 2x minus 1 is a factor of this particular expression. So this is how we will be able to use remainder theorem and factor theorem in different situations. Thank you so much everyone. If you like this video, please do subscribe to my channel and give a thumbs up and share it with your friends. Thank you so much.